I'm Anjali Pattapure and I'm presenting the topic on cluster analysis. So first, what is cluster analysis? Cluster analysis or simply clustering is a process of partitioning a set of data objects into subset. Each subset is a cluster such that objects in a cluster are similar to one another and similar to objects in other clusters. Cluster analysis have been widely used in many applications such as business intelligence, image pattern recognition, web search, biology, and security. In business intelligence, clustering can be used to recognize a large number of customers into groups. In image recognition, clustering can be used to discover clusters or subclasses in handwritten character recognition system. Suppose we have a dataset of handwritten digits where each digit is labeled as either 1, 2, 3, and so on. Clustering has also found many applications in web search. For example, a keyword search may often return a very large number of hits due to the extremely large number of web pages. Next, requirements for cluster analysis. In that first one, scalability. Many clustering algorithms work well on small datasets containing fewer than several hundreds data objects. However, a large database may contain millions or even billions of objects. Second one, ability to deal with different types of attributes. Many algorithms are designed to cluster numeric data. However, applications may require clustering other data types such as binary, nominal, and original data. Next, discovery of clusters with arbitrary shape. Many clustering algorithms determine cluster based on Euclidean distance measures. Algorithms based on such distance measures tend to find spherical clusters with similar size and density. Requirements for domain knowledge to determine input parameters. Many clustering algorithms require users to provide domain knowledge in the form of input parameters such as the desired number of clusters. Consequently, the clustering result may be sensitive to such parameters. Ability to deal with noisy data. Most real-world dataset contains outliers, unknown or data. Sensor reading, for example, are often noisy. Some reading may be inaccurate due to some sensing mechanisms. Incremental clustering and insensitive to input order. In many applications, incremental updates may arrive at any time. Some clustering algorithms cannot incorporate incremented updates into existing clustering structures. Capability of clustering high dimensionality data. A dataset can contain numerous dimensions or attributes. When clustering documents, for example, each keyword can be regarded as a dimension and there are often thousands of keywords. Constraint-based clustering. Real-world applications may need to perform clustering under various kinds of constraints. Suppose that your job is to choose the location for a given number of new automatic teller machines in a city. To decide upon this, you may cluster household while considering constraints such as the cities, rivers, and highway networks and the types of numbers of customers per cluster. So next one, overview of basic clustering methods. There are many clustering algorithms in a literature. It is difficult to provide a categorization of a clustering methods because these categories may overlap so that a method may have features from several categories. In that first one, partitioning method. Given a set of an object, a partitioning method constructs k partitions of the data where each partition represents a cluster and kn. That is, it divides the data into k groups such that each group must contain at least one object. In other words, partitioning methods conduct one-level partitioning on data sets. The basic partitioning methods typically adopt exclusive cluster separation. Most partitioning methods are distance-based. Given k, the number of partitions to conduct. A partitioning method creates an initial partitioning. In that, uses an iterative relocation technique that attempts to improve the partitioning by moving objects from one group to another. In the second one, hierarchical method. A hierarchical method creates a hierarchical decomposition of the given set of data types. A hierarchical method can be classified as being the either agglomerative or device based on how the hierarchical decomposition is formed. So first, partitioning method. The simplest and the most fundamental version of cluster analysis is partitioning, which organizes the object of a set into several exclusive groups. To keep the problem specification concise, we can assume that the number of clusters is given as background knowledge. Formally, given a dataset D of objects and K the number of clusters to form. A partitioning algorithm organizes the object into K partition, where each partition represents a cluster. In that K-mean, a centroid based technique. Suppose a dataset D contains n objects in Euclidean space, partitioning methods clustering the object in D into K cluster. See that CCD and CNC. An objective function is used to assess the partitioning quality so that objects within the clusters are similar to one another but dissimilar to object in the other cluster. A centroid based partitioning technique uses the centroid of a cluster C to represent the cluster. Conceptually, the centroid of a cluster is its center point. The centroid can be defined in various ways, such as by the mean or medoid of the object. In that algorithm, K-means. The K-means algorithm for partitioning where each cluster center is represented by the mean value of the object in the cluster. In their input is K, the number of clusters, D, a dataset containing an object, and the output is a set of K cluster. There are some methods. First one, arbitrarily choose K objects from the initial cluster center. Then repeat. Then reassign each object to the cluster to which the object is the most similar based on the mean value of the objects in the cluster. Next, update the cluster means, that is calculate the mean value of the objects for each cluster. And last one, until no change. And the second one is K-medoids, a representative object based technique. The K-means algorithm is sensitive to outliers because such objects are far away from the majority of the data, and thus when assigned to cluster they are dramatically distort the mean value of the cluster. And the algorithm of K-medoid. A K-medoid algorithm for partitioning based on medoid or central object. And the input is K is a number of cluster, D is a set of containing no object, and the output is a set of K cluster. And there are some methods. In that first one, arbitrarily choose K objects in the initial representative objects. And second one, repeat. Assign each remaining object to the cluster with the nearest representative object, and randomly select a non-representative object O random I. Compute the total cost S of swapping representative object OJ with O random I, and if S is smaller than 0, then swap 0 with random I to form the new set of K representative objects, and until no change.